Oh hey, you just caught me practicing magic. But I know what you're thinking. I'm in a lab coat. I should be doing science. Well, I am. I'm doing magic and science, because magic is always science, but science is never magic. As we'll explore in our lesson today in Hocus Pocus, Science Focused. Alright, so for our first trick, we're going to be making phoenixes rise out of the ashes. Bam! So we got our tea bags, fire. Wow, wasn't that fun? So this experiment seemed to be a phoenix being born from the ashes and flying up into the air. Crazy magic, right? It was actually pretty simple thermodynamics. We set these bags on fire, hot air rises, so the hot air lifted up these light ashy tea bags as they burnt. For this next experiment, we're going to continue to use fire, but instead of making fire, we're going to be extinguishing it. I'm going to do this not by blowing on it, not by dumping a liquid on it, but by using science. Let's watch. Did you see that? Now what I did was made a chemical reaction in this flask. I combined baking soda, that was the white powder, with vinegar, the clear liquid. Those two combined in this flask and formed CO2. CO2 is a heavy gas, so I was able to pour the gas out onto the candle. Now fire needs oxygen to survive. The CO2 was so heavy it pushed out all the oxygen and suffocated that fire, depriving it of oxygen and extinguishing it. We're going to use that same chemical reaction with vinegar and baking soda to inflate this balloon. Whoa! Fun stuff. We made CO2 and it filled the balloon. Nice. What's up? Does anyone know what makes soda fizzy? Well, it's CO2. We're going to be experimenting with CO2 in a different way. Woo! That was exciting. So we used Mentos. We just dropped them into this soda, this cola. Now, the Mentos, they're covered in dimpled sugar. And the CO2 that's in the cola, it wants to escape from the cola. So it rushes to the sugary coating of the Mentos, causing the Mentos to lift up, float. Once they're floating, the CO2 is able to escape from the soda, go into the air, causing this reaction. I tried drinking that cola from the last experiment, it didn't taste very good. It was very flat because we took all the CO2, all the carbonation out of it. I think I'll try drinking something different. Whoa! My drink was green, and now it's yellow. What happened? Well, I kind of tricked you. In this cup, I put water and universal indicator. Universal indicator changes color based on if something is acidic or something is basic. Now, I didn't drink the liquid, I was actually blowing into it. Do you know what we blow out, what we breathe out? It's CO2, or carbon dioxide. So I was putting carbon dioxide into this solution, kind of how we were taking carbon dioxide out of the cola. Now, carbon dioxide is an acidic compound, so I was making my solution here more acidic, and the color changed to yellow. Now remember, science is never magic. But magic can always be explained with science. Alright, we've been having a lot of fun doing experiments. I think it's time to play a little game. This is going to be a science memory game, and I'm going to need your help. So what I'm going to do is I'm going to take some regular old water. I'm going to pour it into one of these 3 cups. Then I'm going to shuffle these cups around. I'm going to need you to pay attention to what cup I put the water in. And after I finish shuffling them, I want you to choose which cup the water is in. So, let's start. And I think I will add my water to maybe this cup on the left. Alright, now remember, pay attention to where this cup ends up. Did you watch closely? Now, who thinks the water is in this cup? Let's find out. Guess the water's not in this cup. Who thinks the water is in this cup? Let's find out. Guess the water's not in this cup. So, who thinks the water is in this cup? I know what you're thinking. If it wasn't in either of these cups, it has to be in this cup. Let's find out. I guess there's no water in this cup either. So, if the water wasn't in this cup, it wasn't in this cup, and it wasn't in this cup, where did it go? Well, I actually tricked you. I poured it into this cup originally, but before I put water in here, I put something called water lock powder in there. When water lock powder meets water, it creates this goo. This goo got stuck into our cup, and I was able to shuffle it around and trick you. Isn't science fun? I think it's time for a science investigation. Let's investigate this. So something's happening here. What do you think it is? So my first observation would be there's a gas. That's what all this wispy, smoky bit is. But what is this gas? I'll give you a hint. We've been talking a lot about it. Any guesses? That's right, it's CO2. carbon dioxide. So when we put the baking soda and vinegar together, we made a reaction which created carbon dioxide. In this, we are not creating carbon dioxide, we're just releasing it from a solid form. This is carbon dioxide that has been frozen. Just like water freezes, this is a frozen bit of carbon dioxide. However, unlike water, when water gets hot, it turns from a solid to a liquid. It just becomes liquid water. And then as you continue to heat it, it becomes steam and a gas. This goes directly from the solid form to the gas form. That's a process called sublimation. Can you say sublimation? Try it. Science is a lot of fun words. So you might see there's a liquid in this flask. That's actually just regular old liquid water. There are bits of frozen dry ice or carbon dioxide in this flask. The water is actually just warm enough where it heats the dry ice and allows it to sublimate at a quicker rate, producing all this fun gas. You see those chunks down in there? Now, dry ice is very cold. It's so cold that it could hurt you. That's why I'm wearing this protective gear. Always be safe when practicing science. Now, we're going to do some more fun activities with dry ice. But before we do, I think we need a little history. So, right here I have a quarter. There's a president on this quarter. Can anyone tell me who this is? This is George Washington. He was our first president. But before he was president of the United States of America, he was a general in the Continental Army. He fought in a very important battle called Valley Forge. Valley Forge was in the winter. It was very cold, a lot of snow. So I'm going to do my best interpretation of the Battle of Valley Forge. That's George Washington. He's real cold and he's shivering. Oh, I'll help him out, get him out of that cold, warm him up. But why was this quarter vibrating? Well, this dry ice is so cold that when it gets this quarter really cold really quickly, it vibrates real quick. Now, I have another coin here. This is a penny. Another coin with the US president on it. Does anyone know who is the president on the penny? It's Abe Lincoln. And a little known fact about Abe Lincoln is he really liked to sing. Now, if we listen real close, we might be able to hear him sing. I didn't say he was a good singer. Do you think we can get them to sing a duet? Beautiful. Now this dry ice is very cold. When doing that penny trick where I used my bare hand, I was very, very careful not to touch it. Whenever touching the dry ice, I will be using a thick glove to protect myself. For our next little bit on dry ice, we're just going to go back and look at what happens when we put dry ice into water. This is just water with a little bit of food coloring. Here's my chunk of dry ice. The frozen CO2 is instantly sublimating into a gas. It bubbles up through the water, poofs out. Poof, poof, poof. That's pretty neat. And if you ever go to a haunted house, often they will use this to make fog and set the spooky atmosphere. Ooh. In this flask, I have water and dry ice again. We're producing this gas. We were able to blow up a balloon using the CO2, the gas. Let's see what else we can do with it. We can blow bubbles. Neat. Let's try that again. And here I just have soapy water on a paper towel. Ooh. Hopefully this one gets big. Let's try it with that old cup I had before. Now here's the cup with the green food coloring water. Now, this isn't easy, so let's see if I can do it within the first 3 tries. There we go. Now we wait. Now, this bubble is actually taking a long time to form. It's because the little bits of dry ice we have in here have actually gotten smaller and smaller and smaller. So there's less surface area, so they're producing less gas as they sublimate into gas. So the transition is slower. For our next experiment, we have a cup of really soapy water. We're just going to dump a piece in. Ooh. Come around here, look at this. Alright, time for another game. Again, I'm going to need your help. So, I have a paper cup. I've decorated it nicely, as you can see. I have a little tinfoil ball, which I've gone ahead and just crumpled up a bunch of tinfoil and made it into a ball. I want you to follow along and see if you can find out where the tinfoil ball is. Pa! Where do you think the tinfoil ball is? Right underneath where I left it. Well, alright, I'm going to take this, pop it into my pocket. So, where is the tinfoil ball? Do you think it was in my pocket? You weren't paying attention. It's under the cup. So, I'm going to take our tinfoil ball, put it in the cup, pour it in my hand. Where do you think the tinfoil ball is? Again, you weren't paying attention. It's in my pocket. Alright. Try one last thing. We're going to throw it back in my pocket. Ha! Where's our ball? Again, underneath the cup. How am I doing this? Well, I've been tricking you. I've had 2 tinfoil balls this whole time. One is magnetic, one is not. I have a sneaky little magnet at the bottom of my cup, allowing the ball to stick. For our next experiment, we're going to do this in complete darkness. Okay, maybe not complete because I have this light here, but it's going to be pretty dark. What do you see before you? I'll tell you what this is. This is just a jar of tap water. Now our next little session is going to be a lot of observations. So let's start by making observations about this water and the light going through it. The flashlight, does it go through as a beam? Does the water glow? Just take a second and think about what you see. Next, we're going to add some vegetable oil. Again, I want you to think about what you see, make observations. Neat. Talk with your neighbor about what you just saw and what you continue to see. I'll tell you what I see. I see two different layers, the water and the vegetable oil. These two separate out because they have different densities. Next, I'm going to add some food coloring. Again, I want you to think and make observations. I added 3 drops. Now, what do you see? I'll tell you what I think I see. The food coloring stayed on the top vegetable oil layer and is not mixed in, but remains as these small little bubbles. Can you see the bubbles? There they are. 1, 2, 3. For our next step, I'm going to add some Alka-Seltzer. Here's my little tab. You gotta just drop it in. I'm gonna add a second one. What did you observe? Take a second and talk with your neighbor. I'll tell you what I observed. When the Alka-Seltzer was dropped in, it began to form bubbles. These bubbles disrupted the vegetable oil layer on top, releasing the little orbs of food coloring. Food coloring is mostly water, so when it was released down into the water, it was able to form up and join with the water, making the whole solution green. Neat. The vegetable oil stayed on top. Alright, for our grand finale, we're going to have a mystery chemical reaction. Now, I know what these chemicals are, but I'm not going to tell you. We're just going to mix them together and see what happens. Let's do it. Goopy yellow liquid. And other liquid. Scrape it all out. We're gonna mix. Mix like crazy. We've got some color changes happening. Keep mixing. Keep mixing. Still going. Oh, is this another color change? Yes. Now the liquid is starting to expand. Let's watch. It's like a mushroom. Now it's pretty hot. This thing is getting warm and giving off heat. Now it's kind of solid. Look at this thing. There's our cup. I know you can't feel it. This thing is pretty warm. Science. Thanks for joining us for Hocus Pocus with a science focus. See you next time.